Alright, hi everyone. This is the last example of chapter 1. It is a special question. It is question 14 from the page 33. Let's read the question first. Question 14. Two small balls, each of mass 0.1 kilogram, are attached to silk threads 1 meter long, which are in turn tied to the same point on the ceiling, as shown in the figure. When the balls are given the same charge Q, the thread hang at 25 degrees to the vertical. What is the magnitude of Q? So hint, draw a force diagram. I always draw a force diagram, but just to make sure you don't forget. On the diagram, what we are seeing over here is we're seeing two balls that are hanging with a 25-degree angle. We are given some important information. We're given that the length of the silk thread is 1 meter. We're also given that the mass of the ball is 0.1 kilogram. And we're looking for the charge. We're also told that the charge has to be the same. So they have the same charge and they have to be both positive or both negative because clearly they repel each other in this case. All right. Now, the first thing we need to do is draw a force diagram. Now, as a reminder, might have been a while, there is 3 forces acting on either of these balls. Now, because both balls share the same mass, they share the same charge, we just need to solve one of the force diagram for either of the ball to get our answer. So I'm going to choose the right ball, but if you decide to choose the left one, everything will be the same, but in mirror. The force will all be mirror, pointing in the opposite direction. So we are looking at the force acting on the right ball over here. We have the force of gravity pointing downward. Now note that in our force diagram, the XY axis, the force of gravity is always pointing in the negative Y direction. All right. The electrical force, if we look here, they both share the same length, so the same hypotenuse. They both share the same angle, although it's not exactly written in the diagram. They say it's the same angle, so 25 degrees also here. So that means the force has to point strictly in the X direction. So the electric force that repel both balls is in the X direction, and for this one it is in the positive X direction. Now let's look at the tension. The tension is not exactly obvious. You might have to have a good look at it, but it is 25 degrees with respect to the positive Y-axis. Now a trick I like to use to make sure I don't make a mistake with this is if the ball were hanging with right in line with the force of gravity, the rope will be pulling the ball upward, counteracting the force of gravity. Therefore, the tension will be pulling upward. Now, what we're doing here is we're pulling on the ball slightly, 25 degrees. So the angle is to the left by 25 degrees. All right. An important piece of information that is told in the problem is the ball are stationary. They are holding there in the air. That means the net force on these balls has to be equal to 0. There's no acceleration. It's not moving. The net force has absolutely to be 0. Net force is equal to tension plus force of gravity plus electric force is equal to 0. Let's consider the X and Y component. So for the X component, if we look at the force diagram, there's an X component for the tension. There's obviously an X component for the electric force. There's no X component for the force of gravity. Let's consider first the X component for the tension. If we were to draw a triangle and close this right triangle here, what we will see is the Y component for the tension is pointing the positive Y, and the X component is pointing in the negative X. So it's a minus. Also, the X component will be opposite to this angle. So we will need to use sign. So we have minus the magnitude of the tension multiplied by sine 25 plus the electric force. As you can see, the electric force is pointing in the positive X direction, has to equal 0. All right. Now at this point, we don't know the tension. We don't know the electric force. So we need a second equation, and obviously it will be the Y equation. So the force in the Y direction, if we look over here, the electric force has no component in the Y. The force of gravity is strictly in the Y. It is actually in the negative Y. And the tension, again, the tension is positive in the Y direction. And since the Y component will be touching the Y-axis, adjacent to the angle, we would need to use cosine. So the tension is positive in this case, so it is equal to tension multiplied by cosine 25. And the force of gravity is simply equal to the mass times the gravitational acceleration, so mg. So minus mg equals 0. And once we input everything, we get a tension of 1.08 Newton. All right? Now that we have the tension, we can go back to our first equation and simply input the value for the tension and isolate the electric force. So if we look here, basically we can take that term, flip it on that side, and we end up with tension multiplied by sine 25 is equal to the electric force is equal to 0.456 once we input the tension over here multiplied by sine 25. Now I will need to erase this section at least to complete the problem. So pause the video. Now if you need to write any of this down, I will need to erase some material. Alright, so note, now we know what the electric force is. It's 0.456 Newton. Now we're looking for the charge, but we are also missing the radius or the distance between the two charges. This is our R over here. But note, we are told that the length of the silk thread is 1 meter. So that means this side over here has to be equal to 1 multiplied by sine 25. So that means the radius has to be twice that amount. The radius is 2 multiplied by sine 25. So at this point, what we need to do is simply isolate the charge. So we have so once we isolate the charge, we get a charge of 6 microcoulomb. All right. So it's a different kind of problem. You need to use some of the technique you develop in the mechanics section, but it's an interesting problem nonetheless. So that's it for chapter 1. Make sure you practice all these exercises, and you will see all these concepts in the first test. That's for sure. In the next video, we're going to be starting chapter 2, which is the study of electric field. All right, see you in the next video.